Hi everyone, in this video I am going to explain about demultiplexer and we will see what are the different demultiplexers available, and also I will give you the VHDL code of the 1/2 demultiplexer. So the first one, demultiplexer. What do you mean by a demultiplexer? Multiplexer we have seen in the previous videos, which is an opposite action for the demultiplexer. If you see the demultiplexer, which converts a serial data into parallel data, whereas multiplexer is a conversion of parallel data into serial data. Okay, it converts a serial data into parallel data, Now what is the size of the demultiplexer? Size of a demultiplexer is represented by 1/2 power n. Size of a demultiplexer represented by 1/2 power n. That means it is having one input which can be sent to 2 power n number of output lines, and whereas the particular output line can be selected by n number of selection lines, where n represents the number of selection lines. Okay, suppose this is the demultiplexer we have, and this demultiplexer is having one input, only one input. Okay, this is I. This can be the data on this I may be either 0 or 1. That particular data can be shared among 2 power n number of output lines. 2 power n output lines with n number of selection lines. If you look at the selection lines, the number of selection lines are common in both multiplexers and demultiplexer, but the input and output lines are reversed. Okay, this is 1/2 power n, 1/2 power n demux. Okay, now we'll see what are the different types or different categories of this demultiplexer. So demultiplexers are available as, that means as you are changing the value of n, if n is equal to 1 in the 1/2 power n, in the 1/2 power n, if n is equal to 1, then 1/2 demux. That means one input, two outputs. And if n is equal to 2, then it is 1/4 demux. If n is equal to 3, 1/8 demux. Like this, we have n number of demultiplexers, depends upon the value of n. Okay, now let us start our discussion by taking 1/2 demultiplexer. 1/2 demultiplexer. So 1/2 demultiplexer clearly says that it is having one input which can be sent to two outputs, So two outputs are represented by y0, y1, and input I, or we can say data D, and 1/2 it is having one selection line S. If S is equal to 0, then this data will be connected to y0, and if S is equal to 1, then this data D will be connected to y of 1. Okay, so we will see the truth table also. Truth table for this 1/2 demultiplexer. So D, S, and output y of 0 and y of 1. Now D is equal to 0, selection line is not there, then outputs are zeros, and D is equal to 1, selection line is 0, then this one will be going to the 0th line here, and if it is 1 and the selection line is 1, then it will be going to here. Okay, so where the data D will be going to the corresponding location which is selected. Okay, D here S is equal to 0 means 0th location is selected. Why not? If S is equal to 1 means first location is selected. That's why our data will be going to that first location. Hope you understand. First location, second location, 0th location are nothing but Y0, Y1, Y2 like that. Okay. So now we will see how to write a VHDL code. Before that, we can also just represent y of 0 is equal to, how can you write y of 0? Y of 0 expression, we can simply write the Boolean expression as S bar into D. S bar into D. If S bar is equal to if S is equal to 0, then D will be the output. And similarly, y of 1 is equal to S into D. Very simple expressions. Okay, using this, we will draw the internal structure. Internal structure of Dmux of size 1 by 2. So data D and selection line S, data is common, and S bar. So two AND gates are there for two outputs, y of 0 and y of 1. There is no OR gate here, no need to combine them, because we have how many number of AND gates are there, that many outputs will be there. So S bar D, now S bar D. So D S bar and D S. Okay, this is the internal structure. Now we will see the data flow model of the VHDL code for this. Data flow model. Data flow model. So for any VHDL code, we know it should be started with two lines. One is library, another one is package. So library IEEE use IEEE dot std underscore logic underscore 1164 dot all entity Dmux of size 1 by 2 is port of DS in, these two are inputs, std underscore logic, we don't have any vector, but output is a vector, out std logic vector of, what is the size, 1 down to 0, and Dmux of 1 by 2. Now coming to the architecture part. Architecture, data flow of Dmux 1 by 2 is begin. So here we are writing the behavior of the demultiplexer. So demultiplexer, what is the output? Two expressions we have written. Y of 0 is equal to D into S bar, y of 1 is equal to D into S. Okay, now the same expressions we are writing in data flow model. We know very well, in data flow model directly we are writing on the expression. Directly we are writing the code on expression itself. That's why we can choose, we can directly write it as y of 0 implies D and S bar. S bar can be written as not S. Not yes, you can keep not S in brackets, and this expression will be your, see, I am writing a comment here. This expression is equal to, it is a comment symbol in the VHDL code. Y of 0 is equal to D S bar. This is what the Boolean expression is. and y of 1 is equal to d and s. D and S. What is the output? Y of 1 is equal to D into S. D and S. End data flow. End data flow. This is the architecture of the 1/2 demultiplexer. Okay, very simple. In the next video, I will explain about the structural and as well as behavioral model of the 1/2 demultiplexer. Thank you.